Welcome, everyone. I'm David Habood. Today, we're going to review the new capabilities of Altium Designer 21. The design process often requires repetitive work with tedious tasks. Altium Designer 21 represents a better way to design by revitalizing longstanding functionality and improving the user experience, as well as performance and stability. This is all based on the feedback from our users. So these improvements streamline existing design tasks and empower you to complete sophisticated rigid flex designs with realistic 3D modeling. In addition, Altium 365 continues to play an increasingly significant role with the newest release of Altium Designer. So let's take a look. We will begin with the overhaul of the Spice engine that started in Altium Designer 20. Increased model support and the guided simulation dashboard create an intuitive experience so you can understand your design like never before. Next, we will move through the advances of board shape definition to create even the most complex rigid flex designs. We'll then follow up with high-speed length tuning and design rule enhancements. Lastly, we will review Altium Designer functionality empowered by Altium 365. Keep in mind that this webinar will cover the overall capabilities of Altium Designer 21. We will have dedicated webinars for each of the topics, so keep an eye out for registration. In Altium Designer 20, we introduced a new Spice engine. Altium realizes the importance of spice simulation and the importance to engineers with the focus of improved spice simulation and functionality in Altium Designer 21. This release, we are introducing the simulation dashboard, providing a guided setup for your simulations. With the new simulation dashboard, you get a simple user interface and intuitive simulation flow to make it easier to learn so you can understand your design. The simulation dashboard shows any errors that might come up during the verification, setup, and analysis process of the simulation, and it provides you guidance on where the error might have occurred and how to fix it. To make things even simpler, the new simulation generic components library provides a comprehensive collection of common simulation parts for your initial concept verification. We include a large list of ready-to-use generic simulation models, including models from TI, Microchip, and in the near future, Infineon as well. We also have the ability to import LT Spice schematics to get started quickly. You can import your simulation models, harnessing improvements to the OrCAD schematic and model import engine. Dedicated simulation tools in your schematic editor allow you to stay in the same familiar environment without having to switch tools or user interfaces to run a simulation. Going back to the new simulation dashboard, you can set up, manage, and run simulations from one place. You also can run several simulations and review the results to make necessary adjustments to your components and their parameters. When reviewing the results, you can load these simulation parameters or you can simply delete them from your results list. One of the biggest changes is the new simulation stimulus source interface for voltage and current sources. In addition, there is an area for probe definition. Each probe has its own properties to show the associated net name, simulation results preview, and the ability to set trace color. The quick simulation cycle ensures your schematic and selected components work according to specifications. In turn, you can greatly reduce or eliminate physical testing of board prototypes and perform comprehensive parametric studies. Best of all, you can review previous results to analyze any changes in the circuitry. We have increased the number of supported models to increase the usability of the Spice engine. The comprehensive Spice model support allows you to create unified component definitions directly in Altium Designer with minimal effort to link external models from vendors. So to start off, we have a new Spice Model Library extension, and it's called .lib. So lib files are recognized as combined subcircuit models, allowing direct Spice Model Library file processing in the components panel. You can also directly place Spice Model files, and an automatic component generation occurs. The most frequently used models are supported, including analog PSpice and LT-Spice, as well as digital X-Spice. We also support full Spice 3, PSpice, and LT-Spice digital support is under development. The simulation has multi-syntax support, so models are recognized and combined in the native Altium Designer environment. When the model is placed, the model file syntax is validated to ensure smooth simulation. Together, these improvements make it easier to arrange your model configuration. Plus, there is extended pin mapping support to solve the issue when your schematic pins do not match the number of model nodes. If you can't find models, you can place generic component models to closely approximate your If you can't find models, you can place generic component models to closely approximate your design simulations. Generic models take simulation parameters such as resistance value and tie them to a placeholder symbol. You can then go from simulation to layout in seconds, replacing the generic component with an existing component definition. Okay, we've now switched to Altium Designer. I have here open a Hartley oscillator project. This schematic here is going to be used for simulation. So you can see here, I'm going to open up the simulation dashboard. You can go to simulation dashboard to open it up. So as we talked about, the simulation dashboard allows you to have a guided setup. We're going to start here with the verification of the design. So as soon as we do that, it does an electrical rule check and it checks for all your simulation models. As you see here, we are missing models for everything, but as we mentioned, you have the ability to apply generic models. So you see here, it says, would you like to auto assign models? So I can simply click assign and update the verification, and we see that all of the models have been added except for J2. So we can simply click add model, and it's going to pop up here, and you see that you have the option to get models from your server, local files. We mentioned the .lib files, so we'll be doing that next. You have generic models, and you can actually click Octopart as well and browse through the collection of components here in Octopart, and anything that has models, you can actually select it. But we're not going to do that today. As I mentioned, the .lib, we have this local. So I'm going to do browse. It showed up on my other screen. As I mentioned, this is a PSpice library that is being read in. We have all of the simulation models. We'll go into more detail about this in a little bit. So I'm going to select right here, and you see the information is filled in. The pin model information is synchronized here, and when we go to the model file, we see the model here. Since it is a library file, you can see a lot of models here. We also see the format types. We have Mixim, LT-Spice, PSpice. And as I mentioned, that will be growing in the coming months to support more digital models. As of right now, we support mostly analog models. So now that we have added a model, we're going to click OK. And we see, once again, we update the verification. Anytime there is a change, you must run the verification again. So we come over to the preparation section. As we talked about, you have all of your sources in one area. You can add more sources. You can add probes as you see fit through here. From here, we're not going to actually add anything today. But you see here, you have the 4 different simulation types. Each simulation type allows you to actually have different setup conditions, as you can see. We also separated things such as Monte Carlo simulation, since that is essentially used to supplement these types of simulations. So I'm going to start off by running the operating point. Right, and you see here it starts running it. But when we actually go back, what you can see is the voltage, right? Because I said display on schematic voltage across the entire design here. As we run through the other simulations, you can do DC sweep, come back, transient, and lastly, AC sweep. So you have all of those results. As you see here, the results can be once again clicked on, and they will open up once again. So let's say you need to make some changes and rerun the analysis so you can kind of see the differences. If you look here, you can see show results, load profile, or delete the results if you would like. For the next section, what I'm going to show is we mentioned the .lib files. So if I open up the components panel, we can see all of our component definitions that are in our workspace, but if we come down, I have the local .lib file. So we have all of these defined here automatically based on the models from the PSpice library. And what we see here is if you actually start making, if you place it from the models, it will automatically generate a symbol for you. So we're working on making the symbols a little bit more realistic and usable. So in the future, this type of symbol will look more like this. And we'll do that by kind of recognizing the type of components. But for now, you have this type of symbol available to you. Now let's talk about Rigid Flex a bit. The global market for Rigid Flex PCB was valued at $3.835 billion in 2017 and is estimated to double by 2025. Talking to our user base and analyzing the use of Rigid Flex has shown that there's an increasing utilization of Rigid Flex materials in designs, especially in advanced healthcare devices and high-end consumer electronics. To help with the new design challenges our users face, we have dedicated a significant effort to revitalizing and expanding Rigid Flex design capabilities. We focused this release on allowing design of flexible boards with any popular fabrication technology. The first step was working on enabling complex geometries. You can now edit flexible and rigid regions independently using any freeform shape with the new board planning mode. You can create overlapping and branching regions to create intricate board shapes with ease, such as selective bonding and bookbinding. You can even create rigid flex stack-ups surrounded by cutouts. Additionally, creating and managing bending lines has been improved. The bending lines can be applied to any edge, including cutouts in the board. The bending line definitions remain even after making changes to the board shape definition. Many rigid flex designs often require rigid stiffeners where flex tails plug into connectors and adhesive layers to attach multiple flex stack-ups together. This release adds a workflow for creating stiffeners and adhesives to enable creation of completely new types of rigid flex designs. We have defined a materials library for Layerstack definition, use predefined layers for flex stacks featuring their own specific behaviors and visual representation for a more complete and realistic physical model of flexible PCBs. Plus, you no longer have to individually manage substacks. You can link independent layer stacks to create a continuous board definition. Predefined materials have different impedance profiles and dielectric constant information to realistically model your design. We're going to start off with a stiffener design. You can see here I switched to board planning mode. As I mentioned earlier, the board planning is divided by regions now, or defined by regions. So you see the individual regions here defined. You can have overlap between the regions, and that is determined by priority, which you can see right here. We'll go into a little bit more detail there in a little bit. One nice thing that has been added is because of these independent regions, you can now utilize snapping. You can see right here that in order to get the two edges to meet up, you see the little snapping icon right there, that little circle. So if I want to make it flush, it's really easy to make it flush. So let's go into a little bit more detail in the Layerstack Manager. I can press DK and open that up. We see here R2 with, we named it R2 plus stiffener. If you click this new add functionality, you can see I can add the stiffener or adhesives. So here I'm going to add a stiffener, and you can see that it is added into the layer stack right there. In addition, you can see if you haven't worked too much with this new layer stack document type that was introduced a couple of releases ago, you see that in the properties panel, you can do stuff like define whether the area is a flex area or not. Coming back here, we now have this new layer stack associated here, R2 plus stiffener. If I want to change the color of any region, I simply click here, and it gives me a better visibility of the board overall. I mentioned that if you have a realistic stack up, it's a little bit easier to convey design intent. So here we have a draftsman document of this PCB documents. You can see here all of the different layer stacks available for us, and it'd be really easy for someone to be able to read this and understand the differences between the different layer stacks. Moving on to another design here, we have been talking about the overlapping regions and how that is defined by priority. So if I click here, you see that there are many regions. I'm going to select region F5, which is encompassed by this area here and this little curve. And you can see that I have associated layer stack F5. It has priority 0. We can see over here some more priorities. And the way that this is defined, if a higher priority means that it will take precedent over the other ones. If they are at the same priority level, the stack up with the most number of layers will win out. So coming through here, we have the bend lines. As we talked about, these are now persistent. So if you make any edits to the board shape, you are still able to see these bend lines. They will stay there, and then you can move them over, associate them to the required area. Here in the properties panel, you can define which stack regions are utilizing this bending line. So we see here, we just have F7. For another one over here, we would have F6, and so on. The different regions are really easy to identify in that manner. If we switch over to 2D, we see the whole design with these connectors. We come over to 3D, and as I move this over here, I can hit 5, and it will show us the fully flexed board. We see here there are the overlapping regions and the bend lines as they are defined by region type. Even though these are overlapping, we were very easily able to associate the bend line to the different layers and have this split. One more design we have here. We have this region defined within another region. So this whole, the big region is R1. And you can see here the layer stack is rigid, priority 0. And then when we click again, we can select F3. And we see that this is actually a flexible layer stack. Because it has priority 5, that will have a higher priority than the original rigid layers, which are priority 0. We see the same thing in areas like over here. We can see the different regions. And what's nice is being able to see the different definitions really quickly defined, and I can change these individual shapes if I need to, right? Let's say I need to make this longer or shorter, and it's not going to destroy these bending lines. That's one of the things that was really difficult to deal with before. When you were defining rigid flex designs, the bending lines would disappear when you change the shape. So that's no longer an issue. If we switch over to a 3D view, and once again, press 5 to flex the design. We'll zoom out a little bit, and you see here the area that is overlapped is flex, and we have the cutout here that perfectly cuts out the remaining area of the zone. So we defined a square here within the big rectangle, and then the cutouts to just define that specific area. So I'll flex it once again, and we see over here we have certain materials that split up based on the stacks we've defined, and you can see in certain areas the defined rigid and the flexible area. So if I actually flatten this out again, you see this rigid and then this flat area. When I flatten it out, you're actually able to tell in the layer stack you have the rigid area and then you have the flexible area. So by working with the priorities in the properties panel, you're able to define shapes that would have been incredibly difficult to define in the past, and very easily define them and work with the different types of layer stacks. We also looked at adding the adhesives in the layer stack manager. Similar to rigid flex designs, high-speed capabilities are becoming essential for designs. Clock rise and fall times are faster than ever, so these shorter times make signal switching a serious concern. As mentioned, PCB length tuning is a critical element of high-speed design, which is usually made by careful adjustment of critical net lengths. Altium Designer 21 focuses on improving existing accordion tuning pattern while adding 2 new patterns, trombone and sawtooth tuning. These new tuning patterns are rendered within a tuning sleeve, making it easy to slide the pattern along a route and around corners. All patterns can be applied to single tracks as well as to differential pairs. If you're working with lower speed or lower frequency signals, you can get away with trombone tuning. You'll notice that there are multiple 90 and 180-degree turns in this trace configuration. Using curves for these bends is preferable to using hard right angles, in that it creates a smaller impedance discontinuity. There are a number of different movement and size change behaviors available, depending on where you click and hold on the sleeve. The sawtooth tuning uses a similar polygonal area within which the pattern is built. Here we haven't used any smooth bends along the trace. These dimensions are used to minimize any impedance discontinuities along the length of the trace. They are great in places where building an accordion is almost impossible due to the large number of objects near the track. Accordion tuning and trombone tuning are similar in that they both use a serpentine routing pattern, but accordions help you maintain tighter coupling along the length of the traces. Accordion tuning does not offset the serpentine pattern off to the side of the trace. Instead, it can be routed along the length of the desired signal trace, making accordions a better choice than trombone length matching for high speed differential pair signals. However, in some cases, there is not enough space to build an accordion. To combat the issue of limited space, Altium Designer 21 allows you to rotate the meander construction zone to better utilize space. These three tuning patterns help you to take advantage of specific types of geometries frequently used for high-speed designs. Using these tuning patterns allows you to fully utilize your layout space quickly and efficiently. This release extends routing and glossing improvements implemented in Altium Designer 20 with a strong focus on differential pairs. The first major improvement is differential pair coupling. As you route or drag your differential pairs, they will remain together. The diff pair will move around vias and design objects with ease. Additionally, entry and exit points for differential pairs are guaranteed to be symmetrical. The PCB editor enhancements allow you to take full advantage of the new length tuning capabilities to maximize your routing channels. Previously, you would start with a rule type and begin to apply the rule. This made it very difficult to see every rule pertaining to a design object. The new design rule concepts alleviate this issue by associating rules to individual design objects such as nets, differential pairs, and components. In addition, a new document type has been created to manage and visualize design rules and constraints. The new document allows new functionality with new properties, increased rule visibility, and object-driven design enabling reuse, as well as rule validation. We're also able to use the document to provide future changes and greatly improve functionality at a faster development pace. The new mode allows you to add all critical design elements, components, nets, etc. to a table, and then assign a specific list of rules and constraints to each element. This new mode simplifies the design process with greater interactivity between the schematic and PCB editing environments. If desired, you can choose to revert to the legacy DRC dialog view at any time. Let's see here. We have the mini PC project. I've made a couple of changes to it with some different design rules. So we're going to start off by making sure the properties panel is open. It's really important to use the properties panel while tuning. So the first thing we're going to do is we're going to come down here to the bottom of this VGA, and we see a lot of single-ended traces here. This will be a good area to start showing some of the new tuning. You can see up here in the active bar, you have two types of tuning. You have interactive length tuning and differential pair tuning. So of course, right now we're working with single-ended traces. So we're going to click here, and you could see creating the tuning sleeve very quickly. I'm going to create it like that. And you could automatically start seeing some of the changes here. We have the accordion. As I mentioned, there are different options available now. We're going to start off by moving this around just to see the new changes to the glossing engine. The changes began to be implemented in 8020, and they are further improved now. So we can see you can actually modify the boundaries as you see fits here. Let's say you want to rotate. This is one of the biggest differences here. You can hold the control key and actually rotate the full boundary. As we're working through this, You can hit 3 and 4, right, to make the changes to the width in between. And this has been possible for many years, but just in case you weren't aware of that, 3, 4. There we go. So in addition to that, if you hit space, it's going to change the style, which you can see down here. We can make those changes as need be, and it will automatically change. But again, while you're dragging it, if you hit space, it will automatically make those changes. So I'm going to delete that pattern, and we will switch over to trombone tuning. I mentioned earlier that trombone tuning is pretty similar. The major difference here, if I hit tab, I can come over here without changing the environment. So I'm going to hit trombone. The major difference here between accordion and trombone is spacing situations. A lot of times you're going to want to, generally you would be using the accordion functionality, but let's say you have limited space, like right here. You can see here the accordion tuning is very similar, but it will allow us to better utilize our space here. Let me just create that right there. We can move it to one side if we would like to. See here, moving from one side to the other. And once again, I'm going to hit tab to come over here. And I'm going to do single side. So this allows it to force the system to only use one side. So you can see left or right. And then we come over here. It will very easily go around the corners and automatically follow that. We can change the boundaries as we see fit. If we want to make this a little bit bigger or a little bit smaller, we have that capability. And this single side is really important because it helps you control exactly how you do this length tuning. So lastly, we are going to look here at Sawtooth. So I'm going to make just a couple changes. I'm going to make the angle 70 degrees. I'll make this 154, and I'm going to make the actual height 1 millimeter. Once again, we have the single-sided option, and you can do fixed size if you would like. So I'm going to start off with the single-sided option. And you see here, we can go around some corners if we would like. And the fact that we're single-sided just kind of makes it a little bit easier to see the sawtooth pattern right here along the edge. This is going to be pretty helpful throughout your design process. Some people like to synchronize the sawtooth with the fibers of their design. So that is something that is possible now because you can make this whatever angle necessary for your design. So now that we have this placed here, we are going to add a couple more. We're going to come over here and switch over to trombone tuning. And we add it here. And then lastly, we are going to add one last tuning for the accordion. So you can see them kind of interacting with each other, making sure that they optimize the space with each other. And since you can move them independently, as I believe I mentioned earlier, these are called tuning sleeves. You can see how they interact with each other and they allow you to fully optimize the space here. You still have the ability to drag things over as need be to make things a little bit easier to fully utilize the space of your board. So we're going to leave those there, and we're going to look at some differential pairs. All of the tuning capabilities available for single-ended are available for differential pairs. So we're going to start off by selecting this trace right here. And you can see I'm selecting the inside trace. However, it is keeping them coupled together. So, and this is going to go across these vias, and it's going to keep those together. You still have the push and shove capabilities, as you can see here, but you have that ability to stay coupled. So if we come to the properties panel here, you see in this corner the keep coupled. I can disable that if I would like. And now when I move it, it just moves one at a time. Of course, that's not always ideal, but in the situation where you need to separate them a little bit, you have that functionality. And of course, if you're selecting the outside because of the push functionality of the glossing engine, you will see that it will push over the left one. Okay, from here, we will look at interactive routing for differential pairs. It's the same concept, of course, but with the added functionality of coupling, you are able to better utilize these different tuning patterns. So we see here, I can move it down. As I mentioned, you can hit Control and rotate it. And you'll notice how fluid this is because of these glossing engine changes. It's really easy to move these tunes around. With previous releases, it was a little bit more cumbersome, but now that we have these glossing engine improvements introduced in Altium Designer 20, it's just going to keep getting advancing every single year. So we will look at some of the different tunings. First, we had accordion. I'm using short keys U, P for the differences, hitting the trombone tuning. We have that. And of course, if you would like, you can combine them along the same trace. And you see here with these accordions, it's really nice that you have it's coupled and it's symmetrical, right? One thing we mentioned is the entry and exit of pads is now guaranteed to be symmetrical with this keep coupled functionality that I mentioned in the properties panel. So you can see that the tuning sleeves come in and they interact with each other, so you don't step in on each other's territory. So you can see both of them here. We began changes to the schematic editor in Altium Designer 20. We can briefly go over the most impactful changes for this release. New and improved tools simplify the task of analyzing the connectivity in a schematic project. The Altium Designer Connectivity Insight functionality displays an instant view of the connection relationships within a PCB design project. Shown as a document tree with optional schematic previews, the selectable elements provide a quick and visual way to navigate through a project's connectivity structure. You can effortlessly view and modify net properties for all of your electrical primitives, including the ability to set voltage for power nets and frequency for high-speed nets. The improved net details simplify net analysis and make it easy to understand connectivity across sheets. Simply hover the mouse over a net to examine both the logical and physical net name. Alt-click on the net to highlight that net throughout the project, and Alt-double-click on the net to display a tree of all sheets that net is on. Then click to check out that net in one of those sheets. Adding to this capability is a new hover feature enabled by holding the Alt and Control keys together, which opens a selectable tree view when the cursor is over any object belonging to a signal net. You can also view page references for offsheet connectors. It can be challenging to pick the right components when working on a new schematic. Plus, it isn't always necessary for early stages of development. To expedite the process of laying out the early stages of a design, we've introduced the concept of generic components, which can be quickly placed in a design without the need to find and choose a specific manufacturer part from the available component sources. Generic components are intended as placeholders that are easily replaced by a suitable component later in the design process. They can also be considered as virtual or parametric components. Note that generic components are based on managed component templates in Altium 365, giving you full control over their default properties along with the ability to easily add additional generic components. Each type of generic component has a unique symbol for easy identification and replacement. When you have completed your prototype, you can replace individual components with the properties panel or a set of components of the same type with ActiveBomb. Most modern microcontrollers have multiple package options supporting remappable pins. This release introduces flexible pin to pad mapping capabilities for managed components. Enhancements to the single component editor and the introduction of the new pins panel allow component symbol pins to be mapped to any component footprint pad or any number of footprint pads. The pins panel allows the default one-to-one pin mapping to be changed to a custom relationship, such as one pin being connected to multiple footprints, or any other non-aligned pin to pad number relationship. Pin to pad cross probe highlighting is supported for multiple common footprint pads, and a custom footprint mapping configuration is indicated by its associated icon. A place component with custom pin to pad mapping is fully supported during schematic PCB synchronization for pin and part swapping and by the component pin editor dialog. We're going to start with the Kame FMU project and the CPU schematic. We're going to look right here. You see this label. It indicates that it should be the name of this wire. However, sometimes it could be difficult to follow when you have a lot of different nets. If I hover over it, I am able to see the net name and the physical name. Clicking on it, we open the properties panel. We see the physical name, which is the name on the PCB, and the net name, which is the logical name on the schematic itself. If we have certain nets like a power net or a high-speed net, you can put additional information there for them. If I want to change the color, I can use this option and change the color as need be. If you have a more complicated connection like this FMU harness, I can click it, Alt click, and I am able to see all of the associated connections here. If I want to see if this type of harness or connection in general is connecting to another sheet, I can Alt double click, and we get a navigable schematic tree here. I'm going to navigate over to this other schematic sheet. And once again, all connections associated with FMU are shown here. You can see everything has been dimmed out, so it's very easy to actually see everything connected to it. If I hold Control and Alt at the same time, I get that same type of tree dialog here. So once again, I go to FMU and I can see the different places I can navigate through. And that's going to make it really easy to navigate between connections on the sheets and understand the connections. From here, I want to change it up a little bit. I have the generic components here. They can be seen in the all category. So I'm going to place a resistor here. I'm going to click on it to open up its properties. And we have different parameters here that we can fill out. In this case, I'm going to fill out the value parameter, and I'm going to set it to 1K. And I'm going to copy this a couple times. And paste it. Okay. So from here, there is a way to annotate. So I'm just going to do that quickly, quietly annotate it. It'll give me some reference designators for that. So there's two ways to make changes to these generic components after you have finished up your design. I can replace an individual component in the properties panel with the under design item ID. If I click here, I get the pop-up to replace a component. But when you have several components that have the same type of information, we can also come through the active BOM document and see all of the components. Here we see there's no manufacturer part number. So now I want to change this. I go to operations, change resistor. I want to find an actual part that can be manufactured. I can acquire from a manufacturer. I have several options here. You'll notice that it takes the parametric values I have set and filters for them. So in this case, I just put 1K, but if I fill in more parameters, it will also filter by that. If I do control click and I select multiple components, I can compare them to make a better selection choice. Red are differing parameters and white are the same. In this case, I see there are a lot, the stock is much greater for this top component. So I'm going to select it and I get an ECO that to replace the parameters that are being taken from that component definition. I execute it and I come back over and we see that the components have their parametric information filled out. We have everything here. We also have the footprint, 2D and 3D. So we're able to just lay out whatever we need with these generic components, test out our circuitry, and then replace it with a known component at a later time. The last thing for this, I want to show going back to the components panel. I'm going to place this component. I'm going to place a couple. So you'll notice here that you have 2 pins, but you have 2 numbers here. That means that that pin is mapping up to different pads on the footprints. So if I click in to the properties of this component, I can see that there are a couple options for footprints. So if I go through and change it to the other footprints we have, we can see that each one is providing a different type of pin mapping, different direction of pin mapping. And you can see if we come down to the data sheet opened on the other monitor. We come down to the data sheet and we can see that that is because of this. Each one has a different type of connection. Therefore, we can use one symbol and map it to the different footprints in order to get effectively different components here, different configurations of the same component. Our last topic for today is new functionality enabled by connecting to Altium 365. Remember that access to Altium 365 is provided with your subscription. When you store your designs in an Altium 365 workspace, you can get powerful tools to enable collaboration. Let's start off by discussing project history. Designs stored on your workspace benefit from built in version control. The version control system, or VCS, allows us to create a progressive timeline of all major events in your design process. You can see event markers for who did what, when, and why. Additionally, the system automatically calculates differences between events to analyze changes. Every event can be searched to easily identify and review changes. For example, changes to specific components throughout the design process. When you are done with the design, you can complete a design release. The release creates a full snapshot of all design files and outputs so that you can always know which files you sent to manufacturing. Any changes created after release can be reviewed quickly with the automatically calculated design differences. If you would like to revert to a previous revision of any event, you can simply click on the little dots and select revert to, and your entire project will be reverted to that design snapshot. The automatically calculated differences can also be seen in the web UI. Currently, you get a visual comparison of your Gerber changes to analyze changes directly on your board layout. You can click on the differences on the left column and they will highlight in the graphics. This functionality is currently in beta and will be updated and expanded. When you are collaborating on a design, you often have to work on the same design files. A lot of work is cross domain, making commenting on the design more difficult. We have implemented notifications for file locking to simplify conflict prevention. When you open the file, it automatically applies the file lock for all other users. You can see when someone has begun changes to the design so that you don't make any contradictory changes. If one collaborator ignores the file lock notifications, version control notifies all other collaborators of the file status. When one collaborator edits a document, the other collaborators are informed of the change whether or not they have the document open. You no longer have to rely on emails to communicate thoughts on your design. When your projects are connected to your Altium 365 workspace, you can add comments directly in the context of your design, enabling clear communication while reducing discrepancies and time spent on managing design changes. Simply assign comments to the designated user, and they will see all associated comments on the thread. Each comment thread has its own number for organization and easy traceability. Comments can be added at any point of the design and allows you to select design objects. You can also select an area for the comment to cover. Freehand drawings can be added to supplement the comments to provide more clarity. When reviewing comments, you can toggle the visibility of comment threads in the comments panel to clear up your design environment. You're also able to filter through comments by user, resolution status, and current document. For our final demonstration, we're going to come back to this Comet FMU project and right click on the project name and select history. This is going to bring up our progressive timeline of events. You can see all the different commits of the project here. The automatically calculated differences are shown underneath the comment for the commit. You see here addition, removal, modification of all of these different design objects. For example, we see components here. I can search through them. Let's say I want to know when a component has been changed in my design. Here I put C2, and we could see all of the components that have C2 within their reference designator. This will also work for file names, net information, anything that is being covered in the automatic differences can be searched here. As you can see, also the comments are being searched through. If I go to any individual event and click on these options, I can open up a snapshot of the entire design, or I could revert to that snapshot. So the entire project will change back to this snapshot. We have the release here, all of the associated files with this. You can open the snapshot, compare Gerber files between revisions. I mentioned earlier that the comparison functionality is under development and will continue to grow. So currently you can compare Gerbers, and in the future you'll be able to compare more design information. In the web UI, you also have an ability to clone projects and download the project files themselves. This is going to allow managers, manufacturing, people who don't actually use Altium Designer to interact with the files in, a native environment on the web UI, and they can access it from anywhere at any time. Coming back to the projects panel, we have a couple new icons to introduce. Right here, we see for this file, power schematic, it says open, and Vincent Mazer is editing. As I open the file, I can see Vince here in the corner. I can see that he's editing the design. If I ignore that and I try and make a change, I am warned once again. I can abort the changes, or I could ignore the lock and continue with my changes. So in this case, I'm just going to abort changes, and I'll be able to see the schematic again. If, let's say, I ignored the lock and I continued to make changes, when I save, the VCS system would notify Vince and any other users that change has been made by me. There are another couple icons to show for this. Of course, it's a little bit difficult because you need multiple users to be interacting with everything. But I would say this is the most critical one to understand. The last thing we're going to look at is the comments panel. So we have the comments panel here. This has been updated pretty significantly. If you've used comments in the past, this comment panel now includes an addition to place a component directly on the schematic from the comments panel itself. So if I click place a comment, you can see here I can select any design object, and if I click and drag, it will add a comment for the area itself. We see here we have one comment here associated directly to this design object. Let's say that some change occurs with this object. Whenever you make a comment, a snapshot of the original design is included to ensure that your communication is in the context of the design, right? In case any changes have been made, you are guaranteed to have the original snapshot. So we see here, I tagged Chris, and he got back over to me. Over here, we have filtering options. Let's start with the visibility. So you can hide the visibility of these objects here. You see right here, the visibility changes. Let's say you have a lot of comments on your design. You can just quickly toggle that so that you don't have an issue. The filter options, I can remove all resolved comments. If I undo it, you could see a resolved comment here. I had assigned this comment to Arthur, and he resolved it for me. This is going to give us traceability of changes and actions and just overall feedback on a design. You could also filter by current documents. You can filter from, so I could say, who did, I need to see all the comments from Chris, and I can just select that right there and get that information. That's the end of our presentation. Thank you, everyone, for your time. I will open it up to questions now.